So yes, I'm Alejandro. I'm a solutions architect here at AWS, and I work on Duarte's team. So we both work for the worldwide public sector team. So usually with government, NGOs, so public type of clients. And I think that's pretty much all.
Yeah, I'm going to just unmute Mohammed.
طيب, thank you, Alejandra. Thank you, Mota. We are really happy to have you as part of this session. This session will be completely conducted in English. I just want to thank you, Alejandro and Mora, sorry, for this support because they are supporting in last minute. Really thanks for this. Will be a kind of introduction session for compute and storage. Compute, we are talking about how we are processing your transactions, and storage, how we are going to store any kind of transactions in a different ways. Really thanks for both of you. The first hour, I think we are going to talk about the compute, and second hour will be we are going to talk about the storage. If you are having any questions, we are going to support you. I'm here, and Dr. Ahmed Ilhami will support you in this. Again, thank you, Mora and Alejandro.
All right, thank you.
All right,
Thank you.
great.
Sure.
And yeah, I would say that any questions, you do have the support, but feel free to send any questions that you have to the chat. And because we're going to be here, it's easy to answer briefly if there's any need for it. So yeah, I would say I'm going to leave the floor to Alejandro. Yeah, go ahead.
All right. Can you see my screen?
Yes, perfectly.
All right. I think Mohammed, you raised your hand. Okay, yeah, you're saying you can. Okay, great. All right, perfect. Then we can start, I would say. Okay, so hi everyone. So today we'll take a brief look at the Amazon cloud. I will introduce what this is, and then we will talk about EC2, and I will give a brief overview on that. So as you know, my name is Alejandro. Right, so this is the agenda that we will be following today. First of all, we will talk about what is the Amazon cloud, our global reach, and we will conclude this session by going over the EC2, by going over the overview and the design. Can you raise your voice? Okay, sure. Can you not hear me? All right. All right, great. So first of all, AWS, right? So AWS provides a highly reliable, scalable, low-cost infrastructure platform in the cloud, and it powers millions of businesses in over 245 different countries and territories all around the world. So AWS was born because Amazon.com, we realized that we had over a decade of building and operating the core business, Amazon.com. And also we realized that we had developed these competencies in operating massive scale technologies and data centers. So we embarked on a mission to offer this to developers and businesses to build sophisticated, modern, and scalable applications. So now, what is the cloud? So when cloud comes to mind, there are different things that you might think about. So the cloud is the on-demand delivery of IT resources via the internet with a pay-as-you-go pricing. So it's about acquiring compute, storage, databases on an as-needed basis instead of having to buy, owning, and maintaining your own data centers and servers. So in traditional data centers, obviously the first thing you need to do is buy the servers. So you need to put and have that fixed cost in advance. All right, so some benefits of AWS Cloud. So first of all, it's about the low cost, right? Secondly, it's about the elasticity and agility. So when you're in the cloud, you can select, for example, an instance size. If it doesn't convene you, you can easily scale up or down, and this is done in a very agile way. It's also open and flexible, it's secure. So at AWS, we talk about the shared responsibility model for security, although we will not talk about this in this session. And finally, the last point is about the global reach, right? Because it's very easy to build your applications and scale them for users worldwide. Someone is saying there's no sound.
In my case, I can hear you loud and clear, Alejandro, and I think a lot of people do. So I sent this to the group, to the chat actually, and if you can check your sound settings, so if you click on the sound, you have sound settings, and maybe you have the wrong output. So yeah, for those who can't hear, maybe that's the problem, because we can hear you very good. Thanks.
All right, then we can continue. I'm not sure if there are any questions, but if there are, just feel free to tell me. Okay, so what is our pricing philosophy? So as I said, AWS offers a pay-as-you-go approach for pricing for the vast majority of our cloud services. So with AWS, you only pay for the individual services you need for as long as you need them, and without requiring long-term contract or complex licensing. So it is very much similar like how you would pay your utilities like water and electricity. So you only pay for the services that you consume, and once you stop using them, then that's it. There are no additional costs or termination fees. So AWS's pay-as-you-go model, what it allows you to do as a customer is trade capital expense for variable expense. So this is what we talked about in the previous slide, right? You do not need to have an upfront investment on the servers or on the storage like you would in a traditional data center, because everything is paid as you go. So that variable expense is also much lower than what customers can do for themselves because of AWS's economies of scales. And that allows us to provide even more discounts. So at AWS, there are also different pricing models that allow you to reduce costs by committing to services or resources for a period of time. So for example, you have on-demand instances that let you pay for your compute capacity by the hour or by the second with no long-term commitments. We also have other pricing models like savings plans, which is a flexible pricing model offering lower prices compared to on-demand pricing, for example. We also have the Amazon EC2 spot instances. I will briefly touch upon these in the next slides. But just so you know, the EC2 spot instances allow you to achieve over up to 90% discount compared to on-demand pricing. But they are usually recommended for workloads that can be interrupted. Okay, so now I would like to talk about the AWS global reach. So as you can see, that's a map of all the regions that AWS currently has available. So right now there are 32 regions that are supported, and obviously it's very important for reliability and scalability, and especially latency, to have the workloads closer to your end users. So that's why there are so many regions available, so that you can choose and get the data in the least amount of time possible. So we talked about regions. Now I would like to talk about availability zones. So each AWS region consists of multiple isolated and physically separate AZs. So that's availability zones within a geographic area. So you have there a diagram at the bottom. So for example, in the US East 1 region, which is the North Virginia region, you have, for example, availability zone 1, 1A, 1B, and 1C, as you can see. Sorry. Apologies. So an availability zone is composed by one or more discrete data centers that have redundant power, networking, and connectivity in an AWS region. There's also high throughput and low latency between these availability zones, and they are physically separated with 100 kilometers or 60 miles. Now, this next part is about the Amazon CloudFront points of presence. So Amazon CloudFront is a web service that speeds up distribution of your static and dynamic web content like HTML, CSS, JavaScript, or just image files to your users. So what we say is that CloudFront is a content distribution network, a CDN. And CloudFront has many different points of presence, so 550, over 550 points of presence. And again, this is very important because your users will be hitting these CloudFront distributions with very little latency because of how well the distributions are distributed all around the world. Okay, so now we get to the next part, which is about the AWS Direct Connect locations. So connecting to the AWS global network and within your network is simple. So you can connect your existing data centers or offices to the AWS network by using AWS Direct Connect. And the reason why you would want to do this is because by using AWS Direct Connect, data that would have previously been transported over the internet is now delivered through a private network connection between your facilities and AWS. So this is even a more secure way to transmit and transport data. So instead of connecting to the AWS network over the internet, you would connect over the specific AWS Direct Connect locations. And now we get to the part on the Amazon EC2. And now we'll give a brief overview of what EC2 is. So Mohammed said at the start that there are different choices for compute. So we are delivering a choice in how you consume compute, sorry, to support your existing applications and build new applications in the way that suit your business needs. So there are different options like Amazon EC2, which are virtual server instances in the cloud. There's also Amazon ECS, EKS, or Fargate. So these are Docker container based. And then we've got AWS Lambda, which is our serverless compute offering for stateless code, and Lambda reacts to triggers or events, and it is a serverless service. So with Lambda, for instance, you only pay for the compute time you consume, and there is no charge when your code is not running, right? So you just upload your code, for example, and Lambda just takes care of everything required to run and scale your code with high availability. And you can also set up your code to automatically trigger from other AWS services or call it directly from any web or mobile application. But now let's focus on EC2. So EC2 is a robust, innovative compute platform, and it is really the core of many of our customers and what the business cases they are trying to solve. So it delivers secure, reliable, high performance, and cost-effective compute infrastructure to match your workload needs. There are different types of instances that you can choose from. So general purpose instances, compute optimized, memory optimized, storage optimized. We will get into these in just a second. And you also have the possibility of choosing different types of processors, like processors from Intel, AMD, NVIDIA, or even ones designed by AWS. Then you can also choose local storage and enhanced networking options. And once again, you can choose to pay for your Amazon EC2 instances, thanks to the plans that were introduced at the start. So by using on-demand, spot, reserved, or with the savings plans. Right. So as you can see, this is a table of all the wide selection of instance types that EC2 offers, right? And there are so many because we want to fit every different use case. So the types vary with respect to the combinations of CPU, memory, storage, or networking capacity, and they give you really the appropriate flexibility for you to choose the exact combination that you want. So by the way, this isn't really a comprehensive or exhaustive list of all the different instance types. There are just a few examples from each category, because there are over 650 instance types as of today. But the important part to remember is you should choose an instance type based on your workload. So for example, a general purpose instance will provide a balance between compute, memory, and networking resources, and they can be used for a variety of diverse workloads. So they are ideal, for example, for applications that use these resources in equal proportions. Now, for example, compute optimized instances are ideal for compute-bound applications that benefit from high performance processors. So as you can see, there are really many different types that you can choose from. So I will go to the next slide. Oops, sorry. Okay, so all right. So now this is now with the recent boom of generative AI and artificial intelligence at AWS, we also built our inferential chip to reduce the cost of machine learning inference, and AWS Trainium, which is a high-performance machine learning training chip that has been designed by AWS to deliver the most cost-effective machine learning training in the cloud. So the Trainium chip is used to help customers be even more cost-effective when they're training their deep learning machine learning models. And we offer Amazon EC2 TRN1 instances based on our custom AWS Trainium chips. And the inferential chip is a machine learning inference chip that is custom designed by AWS to deliver high throughput, low latency inference performance at an extremely low cost. So key takeaway from this slide is that AWS has also designed two different chips for that have been optimized for deep learning. Now, I think this slide is quite interesting, and it is quite useful, because now we get to the instance naming and how the instances, what the different attributes mean, right? So, for example, this is an instance name, c7gn.xlarge. So obviously, you might not understand what it is now, but let's go over what this means. So the first letter we see here is a C. So this is the instance family. So this means that this EC2 instance belongs to the compute optimized instance type. So there are different letters based on the instance family. So for example, if it was a general purpose instance, this letter would be an M or a T. If it was a memory optimized instance, it would be an R. If it was a storage optimized, it would be an I or a D, and so on. So the mapping between letter and instance family is clear in the documentation. Next, we have this 7. So this is the instance generation. So usually the recommendation here is to use the latest instance available, because it performs better and it's usually cheaper. However, if for whatever specific reason, you require another instance generation, an older one, we also support that. Now, these next two letters here, GN. So these are the attributes, and the attributes, what they are in this case, they're a combination of the processor. So the G here stands for the Graviton. So this is a processor built by AWS Graviton processor, and the N here stands for network optimization, right? So this is an instance that has been network optimized. And finally, we get to this last part. So I think this is the most intuitive part, right? The X large. So you can think of this as like clothing kind of size, right? So this just denotes the amount of CPU, memory, storage, and network performance. All right, so these are the approximate instance sizes. So first of all, so what we say is that this 8x large, so this is done with the example from the previous slide, the C7GN, but generally it is always like this. So we say that an 8x large is approximately equal to 4x large to 4x large, which is approximately equal to 2x large, which is approximately equal to 8x large, right? So when you're starting your cloud journey, it is important that you right size the instances, right? So right sizing is just basically choosing what instance type matches the workload that you need based on your characteristics, right? But it is also about optimizing the instances in your account once the instances are already running, and in that way you can save. You will be able to save costs. Okay, so instances are as I said before, they are at the heart of most customer workloads, and EC2 offers the broadest and deepest compute platform with over 650 instances and the choices of the latest processor, storage, networking, and so on. So at AWS, we are always innovating to give you new instances with competitive pricing and performance. Because we have over 650 instance types, so we are constantly innovating and trying to come up with the best solutions for our customers. Okay, so this is just a very brief slide about storage and memory. So Duarte will talk about this in the coming slides. But basically, as an introduction, what I would like to say is that storage is independent of compute. So you can scale you can scale up or down storage or compute without affecting the other. You can allocate drives known as EBS volumes that support up to 64 terabytes per volume, and some instance types provide physically attached what we call ephemeral storage. So this is just ephemeral storage. So basically, it is temporary. Okay. So this next part is about the EC2 operating systems. So as you can see, we offer a wide range of operating systems, right? Remember that EC2 is just our virtual servers in the cloud. It's one of our compute offerings. So as you can see, you have here a wide range of operating systems that you can choose from Windows Server to Mac, Ubuntu, you know, so really you have quite a lot of operating systems to choose. Okay, so now the Amazon machine image. So an Amazon machine image provides the information required to launch an instance, right? So it is supported, and it is a supported and maintained image that is provided by AWS that provides all the information required to launch an instance. And you need to specify an Amazon machine image or an AMI when you're launching an instance. You can also launch multiple instances from just one AMI. So what could be done, for example, if someone configures the AMI, and then they save that AMI, and other users from that account, for instance, can use that AMI to start other instances. You can also purchase Amazon machine images from a third party, including AMIs that come with service contracts from organizations such as Red Hat. Or you can also create an Amazon machine image yourself and sell it to other Amazon EC2 users. Okay, so now we get to the different purchase options in Amazon EC2. So the first purchase option is probably the one you're familiar with. It is the on-demand purchase option. So on-demand, with on-demand, you pay for compute capacity by the second, and there are no long-term commitments. So the recommendation for on-demand is when you have spiky workloads to define needs. The second purchase option are the reserved instances. So in this case, you make a 1 or a 3-year commitment, and you receive a discount related compared to on-demand prices. And this is for committed and steady state usage. Then the third option is the savings plan. So the savings plans, they also offer great discounts, like Amazon EC2 reserved instances, but they are more flexible because you're not committed to just one instance type. So they are for committed, flexible access to compute. And the last option that I talked very briefly about at the start are the spot instances. So the spot instances, they offer up to 90% discount, but you should really use them for fault-tolerant, flexible, and stateless workloads. Because what happens is that AWS can claim your capacity to run other workloads, like on-demand or reserved instances workload based on your, just on-demand workloads based on your capacity. And that is why they offer up to 90% discount. So you should be using them, for example, for jobs that are fault-tolerant, flexible, and stateless, right? So you have, for example, a processing job that runs maybe once a month and doesn't need to save data, then it can be interrupted. You can choose spot instances, and you will get quite a discount. So summarizing, the recommendation is to use reserved instances and savings plans for known and steady state workloads. You can scale using on-demand instances for new or stateful spiky workloads. And finally, you can also scale by using spot instances for flexible and fault-tolerant workloads. Right, so now this last part is about one security feature of the EC2 instances, which are the EC2 security groups. So the security groups are a virtual firewall. So there you have this image here. This is a screenshot from the EC2 console. and it shows you, for example, 3 types of security rules, right? So here we're allowing an SSH connection coming from this address, right? Now here we're allowing an HTTP connection coming from everywhere, right? So this means everywhere, anywhere rather, and basically that's it. They allow these security groups also they act at an instance level, right? So you need to set these security groups at the EC2 level, and they allow you to control access into your account. So, for example, you might just be using an account for as a web server, so therefore you only allow HTTP traffic, for instance. Or you might want to SSH just from your own IP address and deny other connections. So you could customize that in here. Okay, so now for the EC2 specific credentials, right? So now imagine you need to, and this is done quite a lot, you need to access your EC2 instance, right? So Amazon EC2 uses public key cryptography to encrypt and decrypt login information rather than using a traditional password. So the public and private keys are known as the key pair. When you launch an EC2 instance, you can specify an existing key, or you can create a new key pair. For example, for Linux instances, the private key allows you to securely SSH into your instance. And for Windows, the private key is used to decrypt the local administrator password. And also, very important, Amazon EC2 doesn't keep a copy of your private key. So there is no way to recover the private key if you lose it, right? And that's it. That was a basic introduction into EC2. Are there any questions?
There were some questions in the chat, but
All right.
I think I was able to answer most of them. I don't know if anyone wants to ask something right now. Oh, thank you for pointing out where the GPU instances were.
Hold on.
You have a question. What's the difference between savings plans and on-spot plans?
Yeah. So spot with savings spot, what Amazon does, what AWS does, is it can reclaim your capacity. With savings plans, what you do is you commit to using to spending a certain amount over a period of time. So therefore you will get discounts from it, and your workload, more importantly, it cannot be interrupted, right? So with Spot, AWS reserves the it can interrupt it. With savings plans, with the instance that you choose inside those savings plans, you will always have access, and that instance will always be available to you. I don't know if I answered the question, if that was any clear.
Clear answer.
Okay.
Okay. Are there any other questions? So we can take a 15-minute break, if you all agree, and then we have the second session, which will be a quick session about storage. Will the slides be available? Let me speak to Mohammed Salah, who is organizing the session, and I can see if he can send us our slides through him to you. All right. Okay. Right. So it's 4:37 where I'm at currently, so I'm in my time zone. I would say take at so in 13 minutes at 50 or 10 to 5 in my case, in your case, I'm not sure what's the time zone, but yeah, 12 minutes, and then we're back for the storage presentation.
All right, sounds good.
Okay, so Cairo time is 1 hour later. Okay, from yeah, perfect. Thanks.
All right.
يا جماعة أنا هتكلم بالعربي. سوري Mora and Alejandro, I will talk in Arabic to you guys to understand if anyone is having any kind of questions. Please feel free to send your question in chat. Thank you guys. Shaima, I can send you the full GPU size details. طيب Saif Sulaiman, would you mind to explain more? Do you mean the saving plans, spot instance, or what do you mean by plans? معلش أستاذ سيف، أنا مش فاهم قصد حضرتك بعد إذنك. بما ان حضرتك ما عندكش خلفيه على المجال، احنا هنبعت لحضرتك ماتيريالز توضح الموضوع ده بشكل اكتر وشكل مبسط، يعني لو حضرتك ما عندكش اي خلفيه عن المجال فمفيش مشكله خالص. uh, after 10 minutes the next presentation will start after 10 minutes 5:50. آه، في حد كان بيسأل على الجي بي يوز، فانا بعت حضرتك ارتكل ديديكيتد للجي بي يوز وبتوضح استخدامها ان ديتيلز، لان اغلب الناس اللي بتستخدم جي بي يوز بتستخدمها عشان الماشين ليرنينج يعني، والاي اي طبعا في الاستخدامات التانية ليها علاقة بالفيديو بروسيسنج يعني. بس اللي انا بعته حضرتك ده ديتيلد الجي بي يوز اللي حضرتك محتاجها. I don't understand this session, Marie. To understand the session and to make it very clear, I'm going to send you some URLs to understand it in a more clearer way. طيب I will just send it now, just a second. اللي انا بعته لحضراتكم دلوقتي ده الاسينشال لينك. This is to understand the cloud, to understand the basics, to understand the benefits and what is being explained by Alejandro, but in a more basic way. Please visit this link يعني. Christina, I don't understand your question, please repeat it. What do you mean by plans? طيب دكتور وائل، التكلفة بتتحدد حسب استخدام حضرتك. فلو حضرتك بتستخدم بالساعة هيبقى عدد الساعات اللي استخدمتها. فلو قلنا اليوم فيه 24 ساعة فأنا استخدمت الساعة بدولار، أنا استخدمت منهم 10 ساعات هدفع 10 دولار، مش هدفع 24 دولار. طبعا ده بيديبند على الموديل، لو حضرتك شاري سيفنج بلان أو شارينج سبوت انسنس، لأن ده بيعمل ديسكاونتس بس لفترات أطول. فزي ما كان أليخاندرو بيشرح البرايسنج philosophy behind ده، ان انت كل ما تستخدم اكتر كل ما تاخد ديسكاونت اكبر، كل ما تريزيرف ويبقى عندك لونج تايم كوميتمنت هيبقى عندك ديسكاونتس اكبر. I hope ان الاجابه دي تكون يا دكتور وائل واضحه. Purchasing plans ده for compute instance mentioned by Alejandro. فكريستينا you can have a different purchasing options if you know that I'm going to use the instance for 1 year or 3 years. I'm going to purchase a reserved instance or even a saving plan. Uh, Also, we have a different options like an on-demand option and spot instance. And spot instance is like bidding on your instance, and who is submitting the highest price will get the instance. Let me try to give you a comparison between the plans to make it more clear. Just a second.
So, but Christine, if you're also asking about free plans, so AWS has a free tier option. So there are certain services that belong to that plan, and they are essentially free to use. And that's available with your AWS account directly, if you're concerned about the cost.
Okay.
Hey, for the person that asked, is that presentation acts as an advertisement for Amazon Cloud Services? How are you going to benefit from that? So in this case, these presentations are just a really brief introduction. That's why we're explaining these services step by step. The idea is if this comes up as something interesting, there could be next steps to understand the services more in depth.
Okay.
But yeah.
But let me give you sorry Mora for interrupting you, but let me give you the background behind this. This is presentation is not advertising. This is first we are informing you about the technology itself and how technology is working, the standards of the technology, and then we are explaining the AWS service for those technologies. The main objective of those sessions to enable the academic staff to understand the standards and the new technologies, and also understand the AWS services behind those technologies, and to get use or benefits from that. You can get a lot of benefits because you can update your curriculum with the latest technologies that you can use for AI, for machine learning, even for compute, to know the up-to-date models to the deployment for your compute instance, or even for containers or Kubernetes cluster to do orchestration. This will help you a lot and help your students to understand the new technologies well. This is just to make it very clear. Please provide and send those URL background information for all participants. I already sent this to all of you. I don't understand this session. I shared Dr. Rabab with you the basics, and based on this basics, this session is recorded, so you can come back to the session to understand it in a more clear way. Please could you send those background information URLs for participant? Just a second, I will send it back again. Mora, I believe we can start now, right?
Yes, we can.
Yeah.
Let me just put my presentation here.
I will put myself in mute, and please enjoy Mora presentation.
Okay. Let me just grab the presentation, share, and sorry, I have to find it. Screen 2, and then okay. Can you see the presentation?
Yep, we can see it.
Yes, I can. Yes, go ahead.
Good. All right. I'm getting still used to WebEx. Okay. So I'm just, first of all, I'm going to give a really brief introduction to storage in AWS. I'm gonna try to keep it as light as I can, because I understand we have different backgrounds, just like Alejandro did. And yeah, this is just a really brief introduction. And we're going to start with the different types of storage. And so we have block, file, and object storage in AWS. The block storage is a storage type where the data is organized as an array of unrelated blocks. So the data is partitioned into equal sized blocks. And then when the user retrieves a block, the storage system reassembles that block and gives it back as a single unit. So examples of this are like hard disks, storage area network, and so on. For file storage, we have unrelated data blocks managed by a file serving system. And so these files are in a hierarchical order, and you can see this by files being put into folders or pastes. And these can be used, for example, this file storage systems as a single repository to serve different machines that need to access these files. And we're going to see that in a minute. And then we have object storage, which is, when it translates to AWS, it's the most common service which uses object storage. So stores virtual containers that encapsulate the data attributes and metadata, and it's metadata driven. So just to understand two key terms, starting with durability. Durability measures the probability of losing data. And so this is just the differences between having two copies on one site. So what that means is that you have a single site, a single data center, and that data center has two copies on that site. And then copies on two sites has 99.99% of durability. And what you can do in AWS is, for example, having copies in 3 availability zones, and that means 3 distinct data centers. And what that does is having a durability of 11 nines. So just to put that into, of course, this is just an example, but just to put that into something more tangible, 11 nines means that if I store 10 million objects in a storage service in AWS, which has this durability, I would lose one object every 10,000 years. So that's the key term for durability and what it essentially is. Then, in terms of availability versus durability, and so we have availability is another important concept, and that's the percentage of time it takes for some workload in the cloud to be available for use. For storage services, we focus on durability because it's really what's more important in terms of storage. But this is more or less what I was saying before. So in terms of availability, 3 nines means 5 minutes, 4 nines 31 seconds, and then 5 nines 3 seconds. And in durability, that's what I was saying. So 1 in every 10 million. But just as a key concept is basically that durability is the most important when you're storing your data in the cloud. So just a quick recap. We looked at the different types of storage and then these two concepts, which are really important to understand how storage works in AWS. So starting by block storage, we have this service called EBS, Elastic Block Storage. And this service is an easy to use high-performance block storage service, which is designed to use with EC2. So with the service that Alejandro was just talking before. It's like you're putting this into other words. It's like your external storage that you would have on a computer. Now you have this in the cloud with your virtual machine. So this is recommended when the data must be easily and quickly accessible and you need long-term persistence. Also, we're going to talk about this in just a second, but you also have something called snapshots. And so these snapshots are point-in-time copies of your EBS data that can be used to restore new volumes. What is good about this is that these volumes act independently from the instances. And so in the case that you lose that instance for some reason, or you delete it or whatever, that virtual machine, you will keep the storage. So we're going to go through this again really briefly, not to get into much detail, but there are different types of volumes with just like the instances. You have different types of volumes for different use cases. And so and of course they vary both in performance as in price as well. So you can adapt it to your workload needs when you choose which type of block storage you want. But just to go by it quickly, we have on one hand SSD volumes, which are made for workloads that require read and write operations of a small size. And you have these two options, so GP2 and GP3, which are general purpose. And these are just the 2 and the 3 are just the versions of it, essentially. And then you have the provisioned ones, which are for more where you need more performance in your workloads. On the other hand, there's the HDD volumes, which are optimized for big workloads that need higher performance. Yeah, and so you have the ST1s for performance intense workloads that need to be frequently accessed, and then the SC1s that for workloads that don't need to be accessed so often. But yeah, what really is essential to understand here, instead of just getting into the technicality of it, is just that if you need block storage for some reason, there's a SSD and HDD, and you can use a bunch of different block storage types for the workloads that you need in the cloud. And this is what I was explaining before. So you can take these snapshots to use as backups. They're low cost incremental backups of these snapshots. And then what incremental means is just that you create these periodic snapshots. So once you take a snapshot, only the new data is stored. That's what incremental means. So the old data doesn't have to be stored again, so you're not just storing the same data over and over again. And then the agility to quickly restore your volumes across availability zones. I think I saw your comment before what availability zones are. I think they were explained, but this is what AZs are, availability zones. So you can restore those copies across different availability zones. Okay, so going to the shared file system. So now we're talking about file systems. We have Amazon Elastic File System, which means Amazon EFS. And this service, I know there's a lot of information here, but essentially the service provides a serverless file storage service, which allows you to share these files without needing to provision or manage capacity. And so this is exactly what serverless means, is that you don't need to manage anything. You're in the AWS console, and there are different types of ways of spinning up resources, but let's say you're in the AWS console, which I'm going to show you later. You can just spin up this service and you don't have to manage any of the infrastructure behind it at all. That's what serverless means in a nutshell. And so it's a serverless and scalable solution, so no provision, scale capacity, connections, and so on. Elastic, it's what Alejandro explained, how basically most of the resources in the cloud are built, which is pay only for the capacity you used. So you're not paying, you're not provisioning anything, you're just paying for what you're using. And then in terms of performance, as tens of gigabytes of throughput, as a full AWS compute integration, and this is really useful because as Alejandro just explained, there are different types of compute options. So you can have EC2 instances, containers, and even serverless support, and this can integrate with that as a single file server for those compute options. And then again, the durability, that's why I said this would be important later. Designed for 11 nines of durability and 99% availability. And then we're going to get into this right now, which are the 4 storage classes. And this is also important. So in terms of the pricing of this service, you can enable automatic tiering. And so what that means is that we have different tierings, and then you can take a look at them afterwards, that have different properties. And so you have the standard tiering, you have the standard infrequent access, and what that means is that it's for data that you access less, so for files that are accessed in a less frequent manner. And then you have one zone, which again, speaking of the availability zones, it's data that's only stored in one zone. And what that means is that can bring your availability down, but of course that means that the costs are also lower. And then one zone IA, which kind of joins both of these, which is only one zone and data that's not accessed very frequently. And so you can enable automatic cost optimization, which lowers your data from a tier to another and allows you to pay a lot less to keep your data. And yeah, essentially that's it for the file storage. Let's go to the object storage, object stores, and talk about S3. So S3 is the most famous service in AWS in terms of storage, and it's widely adopted by customers because it's very versatile, and it has really a lot of different use cases that it can be used on. And so this service can be used to store all sorts of different types of data. You can store images, you can store videos, you can store logs from for monitoring, for example. You can really store a lot of different types of data. You can store data that will be used for your machine learning models, for example, and so that the data that you're going to train. So this is really useful for that. So these services, we like to say it's virtually limitlessly scalable. And what that means is that you can pretty much store terabytes of data in S3. And then again, like we were saying about so in terms of durability, as you can see, 11 nines, which is pretty high, and again, pretty important because that's what we're focusing more when we're talking about storage. You can use it for static website hosting as well. We're going to see something similar to this in the demo. And then you have a lot of security, compliance, and audit capabilities, which we're also going to check out soon. And this doesn't really matter. It's just the standard storage pricing for US East 1. This is a region. You have regions in AWS, and this is the and we have different prices for them, but this doesn't really matter right now. And so again, just as the other service that we were seeing, EFS, so Elastic File System, has in S3, which means simple storage service, we have different tierings for different types of data. And I think this is really useful because you can have in the standard edition just frequently accessed data, which has millisecond access. But on the other side, completely, you can have S3 Glacier Deep Archive, which is for archive data. Of course, see the difference between how much you pay. So in here, you're paying $1 per terabyte. And then in here, you're paying 0.023 per gigabyte. And so compare gigabyte with gigabyte, this is 0.023. And on this other end, it's 0.3099. So, of course, when you try to retrieve this data, it will take more time instead of millisecond access. But again, this is good to use when you have archive data that you may want to store. And as you can see, I'm not going to get into this all of these with very much detail and big detail, but you do also have something similar tierings like EFS had, like standard IA, that means standard infrequent access. And all of these have different features and different pricings. Another cool thing is that you can also use intelligent tiering, and that means something like automatic tiering, to change your data from one tier to another based on changing access patterns. And so you could have, let's say, data stored in S3 standard and have intelligent tiering that, if the data is not frequently accessed, can pass it to another storage tiering of S3. And that allows you to automatically save your costs because you don't have the data always stored as it is frequently accessed. And then what I was saying here before, let me just go back to this slide. So the security, compliance, and audit capabilities come here with hand to hand with this slide of the management features. Again, there's really a lot to go on, but it's really good to organize your data with S3. You can use tags, prefixes, you can use versioning, which is really important. For example, to prevent accidental deletes, there are other ways of doing it, but you could use versioning to have more than one version of your file, of your data. And then to monitor as well, there's a comprehensive list of other services that you can use to monitor, or event notifications, for example, which notify you each time an object is uploaded into S3. And so in S3, the main term are the buckets, which are where you store your data. And so if some file is uploaded into your bucket, you can have a notification to activate another service, for example. And so yeah, it's really useful in terms of monitoring. There's a very big list that I'm not gonna go on into. Replicate and tier. So this is what I was saying before. The life cycle, intelligent tiering. You can use cross region replication, and then to modify as well. But yeah, in terms of S3, this is more or less it in terms of more compact presentation on the service. And you'll get to see how it looks, at least in a console way. So the look of the service afterwards with our really quick demo. I'm going to go into Storage Gateway. Storage Gateway is a service which allows you to have on-premises access to cloud storage. And then, so this allows you to have access to services like S3 and EBS that we talked about with this on-premise connection. So one of the biggest advantages of having something like this hybrid model, first of all, there are companies who can't afford to have their data in the cloud. And what I mean with afford is in terms of either compliance or whatever it may be. But one of the biggest advantages of this hybrid model is that it allows you to have lower latency by storing some data in the cloud. And for workloads that require quick access, you can have, for example, the local cache for your low latency access. As it's expected, as you may have noticed with most of the AWS services, we also have different types of storage gateway. And so there's a storage gateway family. And so we have file gateway for files, as you may imagine, tape gateway for drop-in replacement for physical tape. We have this Amazon FSx file gateway. So I didn't mention FSx, but it's also a file service for Windows files. So it's a Windows file server. And I didn't really mention it, so I'm not going to go into it at the moment. But you also have something of a storage gateway for FSx file gateway. And then we have volume gateway, which is a block storage on premises backed by cloud storage with local caching. So an option for each of the different types of data. So file, this is file again, and then tape gateway for the physical tape, and volume gateway for block storage. And this is just an example. So this is for file. In this case, you're storing your data in Amazon S3. So you can store and retrieve objects in Amazon S3 using like industry standard file protocols. So you deploy the gateway in your on-premises environment as a virtual machine or as like an hardware appliance. And you can also deploy it as a virtual machine on AWS. And then you connect it to these services, and you can use it for these are the use cases. For example, backup on-premises data that you have here to the cloud, shift on-premise storage to cloud-backed file shares, or low latency on-premise access to cloud storage, which is going back what we have here represented like a local cache, which can be used. And this same example applies. So this is a file gateway, which you would store in S3. As you see, this could the way that this could be used for backup data would be connecting that storage gateway to Amazon S3, and then creating this lifecycle policy, which again allows you to store your data, pass it from Amazon S3 to any other storage class. And what you see here and this little ice thing, it represents Amazon S3 Glacier, which are the tiers that you pay less, but also have a very big retrieval time because these are the ones that are for archive data, like I was mentioning before. So you can do the same thing with Tape Gateway. This is the exact same logic with similar use cases. So on-premises backup again, drop-in replacement for physical tape libraries, and archive to Glacier, Deep Glacier archive. So your tape gateway usually is archive data, which you can then pass again to Glacier, and the same thing for volume gateway. So in this case, we're talking about volume. Remember that this was this is for block storage, so that the EBS service, and the use cases are the same. So this is mainly just to show that you can use this for different types of data with the storage gateway. And yeah, so this was this was a really short presentation on storage in AWS. What we are going to try to do now, and of course there are a lot of different use cases, but essentially what we're going to move on to is a really brief and really simple demo in which we show spinning up an instance in AWS, what Alejandro was talking to us before, so the EC2 instances. And we're going to create this bucket that I mentioned, and we're going to connect these two and launch a really simple HTML page, so you can just take a look at how the services integrate and how they look in AWS, basically. Yeah, so that was it for me. Let me stop talking for a second, and let me go grab my console so I can show you the demo. All right. Is anyone okay with keeping on with the demo? Are there anything you want to? Yeah, I see that Alejandro is talking in the chat. All right. Thanks, Alejandro, for your help. Okay, I'm gonna share my screen. Screen 2.
Just a second, Mora. I will answer just 2 questions quickly
Okay.
on the chat.
Okay.
You can
Okay.
continue.
Go ahead.
No worries, no worries. I will answer this Randa El Anwar, the S3, the reliable, and what is the advantage of using EFS, and also the countries. Fine, خلاص. Let me try to do this during your presentation. No worries.
So I can keep going on with the demo and you take care of it. That's it.
Sure, please do, Mora. Yes.
Okay, thank you. All right, so let me share my screen again. Screen 2. Can you see a terminal?
Yes, I can. Yes.
Okay, and now you're seeing the AWS console. If you want to, anyone can confirm, that would be perfect. If you see the console home.
Yeah, we can see that, Duarte.
Okay, thank you. Okay, this is just a quick example of then how it works. Let me just check if I'm in the correct account. Yes, I am. Okay, and so what we're going to do here is going to be, first we're going to launch an EC2 instance. And so let's go to EC2. So this is how the AWS console looks. This is the regions that I currently have available in my account. There are some regions that are not enabled and you can enable. But in this case, I'm choosing, as you can see, there are different regions here. I'm just choosing Ireland by default, but I could have been doing this in the Spain one. But yeah, let's do it in Ireland. And so what this essentially means is that we're going to spin up an instance right now. And we're going to start by that. And so launch an instance here. So basically what I'm doing now is just launching that virtual machine. We're going to call this demo 310 2023. This is choosing the AMI, so the template that contains the software configuration. And then we're gonna just leave it on default, which is a Amazon Linux AMI. As you can see, there are a bunch of different Linux AMIs, then Mac AMIs, Red Hat, Windows, and there's a lot of them. Even there's a marketplace with a lot of different AMIs that you can choose appropriate for your workload. The instance type, we're gonna leave it at a free tier. So this one, the T2 Micro, is free tier eligible. Let's just keep it like this. This is really simple. And now we're going to use a key pair, and that allows us to connect via SSH to your instance, so secure shell connection to your instance. We're going to create a new one just for the sake of you looking at how that works, which is really, really simple. Just create one, and let's call it demo. I don't know, just something quick and easy. So we create this, and we have the key pair. So the key pair downloads directly to my computer, and now the network settings. So right now we have something called a security group, which allows us to select rules for our instance. So in this case, we're looking at inbound rules. And essentially what I'm doing here is, and you can see, rules with the source of every IP are not recommended. So what I'm going to do is just change this to my IP, and then add a security group rule, and go to HTTP, so we can then connect to it and just use my IP again. And now we have access, inbound access, and to SSH connections and to HTTP connections. And now the configuration of the storage. So this is automatically configures the storage. This is EBS storage, like we mentioned about. And as you see, if you remember the different types of storage that I was mentioning, you can choose them directly here as well. So the cold storage, and then you have the SSD storage here. We're just going to keep it like this, default. Let me just check if everything is okay. So we're launching an instance. We called it today's date. And yeah, everything is set. So demo, instance, and so on. So let's launch it. And now we're launching an instance. So if I go back to my instance portal here in the AWS console, you can see that the instance state is pending, the instance type, there's a bunch of information about the instance here, and we have to let it, it's pending, we have to let it run. So what I'm going to do while the instance is starting is I'm going to go to S3, the other service that we talked about, and I'm going to upload a file here. So I have to create a new bucket as well. I'm going to call it the exact same thing. Let's hope the names have to be unique, so let's hope this name works. And yeah, this we can just leave it all as default. So I'm just going to leave block all public access, not enabling any versioning. Just keep it as simple as possible. And I'm going to create this bucket. Let's see if the name is used or not. No. Okay, perfect. So if we go here, demo 3/10 of 2023, we have a new bucket created, and we can upload our files directly to this bucket. Let's upload the file. I have already an HTML file that I prepared, which is as simple as it gets. So I think it's here, downloads, it's here, index.html. I'm just going to upload it. Upload. Okay. And upload succeeded, so I can view the details below. If I go to my bucket, I have the index.html file uploaded into this bucket. So now that this is stored and this is done, I'm also going to go back to the instances, and you can see that the instance is running. Let me refresh it. So we still have the instance initializing, but while that is happening, I'm going to mention something about security. So I know that today we didn't really go into security of the cloud, but for these services to communicate with each other, we have to give them permission to do it. And this is really to separate any sort of connections to other services and for security reasons. And so what I'm going to do here now is go to actions. security, and then modify IAM role. And IAM is the service that allows us to do this, which means identity and access management. And I'm going to choose the role. I did this before, so I'm not bothering you with creating a role. But I'm going to choose S3 full access. And what that means is that this instance will be able to access all of the buckets full access. So full administrative permission to access S3. Let's update this IAM role and let it initialize. We have to wait just a few, like a minute or something, and let it initialize. I'm gonna keep refreshing. Let's just wait a second. I'm gonna go back to S3 and see if I have everything correct. Yes, everything is in order. Weird. Just let it initialize. As you can see here, we have all of the details regarding our instance. We already have a public IP version v4 assigned, as well as a public DNS name. And if we go here, which is also pretty useful, if we go here to security, we can see the inbound rules. So this, remember the rules that I did before. So port range 80 and 22 for the different inbound rules. So let's check the security group so we can see them. So HTTP on port 80 for my IP and SSH on port 22 for my IP. This is just to show you that it's really easy to change this in your instance. So let's go back and see if this is done. Okay, 2 out of 2 checks passed. It's ready to connect. So what we're going to do next is SSH, which means secure shell connection into our instance with that key pair that we created. So if I click on connect, you see that there's even the instructions done for this, which is great. So let me copy this command and go back to my terminal. So I have the terminal here. I'm already in downloads, and I'm going to run this command, which essentially ensure this key is not publicly viewable. So I could do this without this command, but it's okay. And then SSH, the command to SSH into my EC2 instance. So I'm going to SSH using that key pair. And if everything works fine, I write yes, and I'm now into that virtual machine. So as you can see, Amazon Linux 2023, and I'm no longer inside my profile. I'm inside that EC2 machine. So what we're going to do next is, once we SSH into the machine, we're just gonna follow here this small set of steps, elevating my privileges, and install an Apache web server so we can take a look at that web page really quickly. So I'm just gonna run these commands. Now I'm installing an Apache web server. I'm going to clear this so you can see the commands better. I'm now going to start that web server. And I'm just following steps here. These are like trivial steps. This is just following essentially a workshop about this. And this is just an additional command to configure the web server to restart if it gets stopped. Not that it's gonna happen, but okay. And then what we're going to do is add that file to our directory. So we can access S3 if we want. We're going to run this command to just change our directory. So HTML. And then we're going to copy that index.html file from S3 to our instance. And because I attached that role that allows me to use to connect the instance to S3, I can run this. So AWS S3 ls to see all of the buckets in S3. So if this works correctly, we can see all of the buckets. Let's see if we find our bucket. Here it is. So the demo. I see a comment. The console is too small to see. Is it better like this, because it's always stays the same size, right? Let me see if I can. How is this? Is this better? All right. Can even go one step further. Okay. Sorry for that. So we have now run this command to see the buckets. And what I'm going to do next is just write AWS S3 ls and then S3 dot and then my bucket name, which is here. So I'm going to copy. Perfect. And now we're inside the bucket and we can see the index.html file. And then we're going to mostly use the same thing. Just instead of showing us the files, we're going to copy the file. And we're going to change this to copy. And now we're going to choose that index.html file. So index.html file. And we're going to copy it to this directory. So if I run this, it worked. Okay. So we're going to just check if the file was actually copied by running this command. Yes, the file is here. So it's, as you can see, it's really simple. Let me, yeah, if you can see, it's just a really simple HTML file. And instead of seeing it like this, let's just take a look back into the console and going to my instance. If I click on it, and if I open this address, so the public IPv4 address, this will take a while because usually I just granted HTTP access. So as you can see, this is probably not going to work because we're having an HTTPS connection. And I just allowed HTTP on this instance. So if I just remove that S, we see that we go to the page, welcome to the demo, hello from S3, because this file is in S3. You're currently looking at the web page hosted in EC2. And so yeah, this is the end of the demo. Like you see here, this is just a really quick introduction to this, so you can take a look at the console and the integration. And just to recap, what we basically explored here today was EC2, so the virtual the computers in the cloud, right? So the instances in the cloud that you can spin up as fast as I just did. We looked into S3, basically the main storage service, the simple storage service in AWS. And then we also had a quick peek into the IAM service, mainly just to see that without this, we couldn't access this instance because the S3 bucket, because we didn't have permission to do it. And so, yeah, that was basically it. I hope this was useful. I'm gonna stop sharing my screen now.